Okay, this video is to review Unit 8 on our conic sections. We have a test next class, and so you got this document today to work on, and I told you I'd post a video kind of talking and working through it. So the first question here is write an equation for the graph with vertex 6, 3 and focus 4, 3. Alright, so it would help if you sometimes just sit and graph these. So I would suggest just try to sketch yourself a little picture. It says the vertex is 6, 3, so I have to go over 6, up 3. Okay, 6, 3, there's the vertex. The focus is 4, 3. 1, 2, 3, 4. 4, 3. So if that's the focus, that tells me that this thing, it opens, the focus is always like inside the curve. So, and I look at these problems and only one of the letters is squared, so I knew this was going to be a parabola. Plus, like ellipse and stuff have 2 vertices, and the hyperbola has 2 vertices. So it just said the vertex, so that was kind of a giveaway too. So it looks like it's a parabola, and it opens, because of where the focus was in relationship to the vertex, it opens to the left. So you have to, you could look back at your notes. When the shape opens left or right, then the y part of the problem is squared. Then it has like the y part of the problem squared. If it opens up or down, then it has the x part of the problem squared. Alright, so the vertex is, kind of like the center. The other one said center on the other shapes, but the vertex is kind of like the middle spot. Yeah, this vertex. And it's 6, 3. That's HK in the formula. That's the H and the K. Alright, so your basic formula for a parabola is y minus k squared. I know it's going to be the y part squared, so I know it's going to start with like y minus k squared equals 4p times x minus h. Alright, so to fill in those things, I know that k is 3, so it's going to say y minus 3 squared. Yeah, it's going to say y minus 3 squared. P, we'll get to that. P, this right here, is the distance from the vertex to the focus. And it opens left, so P happens to be -2 in this case. Since the focus is to the left, goes like a negative direction, like to the left is negative. So P is -2. So 4 times -2 is -8. And then it goes x minus h. H is this 6 right here. So it matches with letter C. Okay, so kind of talk you through that one. Alright, the next problem, write the equation for a hyperbola with the foci 4, 0 and 4, 10. The vertices are 4, 1 and 4, 9. Again, I would suggest that you try to draw yourself a picture. I think it really does help. It does take a little bit extra time, but I think it really is helpful. Okay, so it looks like I have to go over 4. Okay, so I'm going to do these vertices first. Vertices are 4, 1 and 4, 9. 2, 3, 4, 5, 6, 7, 8, 9. Okay, 4, 1 and 4, 9. Those are the vertices. Okay, then you have the foci, the focal points, the foci. Those are 4, 0 and 4, 10. So I gotta go up one more. Alright, so I would say you want to find the middle of these. You want to find the center. You want to find the center. If they give you all these vertices and focal points, you want to find the middle, center between these. So like you could take the blue dots or the red ones really, but let's just go with the blue. Find the middle, like halfway between these blue dots. It was 4, 1 and 4, 9. Halfway between 1 and 9. So 1, you know, they're like 8 distance apart, so half of 8 is 4. They're like 4. I have to go up 4. 1, 2, 3, 4. So it's, you know, you think like how far apart these are. 1 and 9, that's 8 spaces apart. Half of 8 is 4, so just go up 4, like add 4 to this. So the center's at 4, 5. That's halfway between 1 and 9. 4, 5. So that's your center. That's your HK in the formula. And it said it was a hyperbola. Well, it's looking like this hyperbola goes up and down. See, it's a vertical hyperbola. And if it's vertical, then your equation should start with y squared. It should be like something y squared minus some kind of x squared. Remember, it'd be like y squared over a squared, x squared over b squared equals 1. And hyperbola formula has a minus here. It'd be some kind of formula like that. And it's vertical, so I knew it started with y. I can tell it's vertical because all these dots go up and down. All right, so the center is 4, 5. That's HK, so it goes y minus h, or sorry, y minus k. I almost said it wrong. I did say it wrong. I'm correcting myself. Y minus k, y minus 5 squared over a squared. Well, we'll figure that out in a second. And then it'll be x minus 4 squared over some number squared equals 1. Okay, so you have to figure out what a and b are. A is the distance from the center to one of the vertices. Okay, so we were just talking about that. That's 4. A is 4. So this a squared, 4 squared is 16. So it'll be y minus 5 squared over 16. Okay, now we have to find b. Well, you have to use the, you can use the focal point. The focal point, the distance from the center up to one of those focal points is 5. That's c. C is 5. And when we learned about the hyperbola, you use the formula Pythagorean theorem, a squared plus b squared equals c squared. So we know a is 4. We have to figure out what b is. C is 5. So 4 squared was 16. We have to figure out what b squared is. So we can, and 5 squared is 25. Subtract 16 from 25. B squared equals 9. B is 3. B squared would be 9. So this would be a 9 here under the formula. So it ends up being letter D on this review. And yeah, if like I could kind of sketch it, it did help to see it's like vertical and stuff. Yeah, it'd be like a ellipse that goes, or hyperbola, excuse me, that goes like this. Just so you kind of know. All right, next one. Which graph below represents this equation? So it has a plus sign right here. Okay, it has a plus sign. That's important to see that. It's plus. If it's minus, it's a hyperbola, like the last one we did. Hyperbolas always have minus signs, something negative, one of the variables negative. This one's plus. So it's not the hyperbola, because it's a plus. Both variables are squared. We talked about this earlier in the chapter. Like question 1, the parabola only has one of the variables squared. So number 3, it's not a parabola either. It has both things squared. So it narrows it down. It's either a circle or an ellipse. Well, if it's a circle, this would have been dividing by the same number. Because a circle, if you think about it, it's like symmetrical, like the same distance up and down and same distance side to side. So it's not a circle either. It happens to be an ellipse because it's plus here, both variables are squared, it's dividing by different amounts at the bottom, so that's an ellipse. Now if you look at the bigger number on the bottom is 25. 25 is under the x. So that's the bigger numbers, like if you see it's under the x, that helps you decide, well, x goes left and right. It helps you decide that this ellipse happens to be horizontal, like it should be wider, bigger side to side. So that puts us at, it would have to be this one. It would have to be this one right here. And like I was saying, that 25 number, that's like a squared and it's under the x. You know, like the distance from here to here is 5. Square root of 25 is 5. That's like a. And the y, under the y is a 9. Square root of 9 is 3. Like the distance here to here is 3. Yep, so it happens to be letter C for this one. All right, we'll keep moving along. The next one, we did quite a few of these the last couple days to review. You need to organize your problem. You have to put 4x squared plus 8x, put your variable x's together, then the y's together, so it has minus y squared plus 2y. And then I would move the plane number 1 to the other side, add 1 to move it to the other side. Then I would divide by 4 on the first set, so you'd have x squared plus 2x, kind of make a grouping out of that. And this next group, you want to divide by negative 1. And then you'd have y squared minus 2y. So you organize it, x's and y's, factor out the leading coefficient. Now you want to complete the square. You want to figure out what number to add in to your problem here, what number to add into your problem here. Half of 2 is 1. 1 squared is 1. This one's 1. Same thing over here. Half of negative 2 is negative 1. You square that, you get positive 1. So that's the process called completing the square. Now we talked about this today in class. When you add a number right here, it is affected by the 4 on the outside. You really just added 4 right here to this side of the problem. So you have to add 4 on the right side of the problem. That's technically 4. 1 times 4 is 4. So you have to add 4 here. And same thing here, I'm using my pink highlighter. The number that we added in there, it's affected by this negative 1 in the front. Negative 1 times 1 is negative 1. So we'll have to add a negative 1 to this side, or just minus 1. It's the same thing. Add a negative 1 to this side. All right, so now we factor. We're almost getting it. We can factor these. If you factor this, it's x plus 1 times x plus 1. So it's x plus 1 squared. Okay, then this is negative 1. You don't really have to write 1. You can just say negative. You don't really have to write the 1 there. It's kind of like understood. Everyone knows it's a 1 there. Okay, and then you factor this, and it should be y minus 1 squared. Because it's like negative 1 times negative 1 makes positive 1. Negative 1 plus negative 1 is negative 2. And then finally add up these, the right side, and you'd get 4. Then you divide your problem by 4, and you get x plus 1 squared minus y minus 1 squared over 4 equals 1. And then it's a subtraction right here, so I know it's a hyperbola. And that's your answer for that one. Okay, now we're going to go on to the back side and look through. We've got a few left. This one says it's a hyperbola. For the given hyperbola, determine the vertex and the foci. So you know it's a hyperbola because it has a minus right there. Okay, so you look at the problem, and by the x and the y, you see plus 3, so remember it's opposite. It's going to be negative 3, positive 2. That's going to be your center. Negative 3, positive 2. That's your center of your hyperbola. Okay, and again, it'll be helpful if we sketch this. I'm going to sketch it here in a second. And then the bottom number below here, that's a squared. A squared is 144. So what does that make a? I'll just put a equals. A would be 12, because that's a squared. A is 12. Okay, then b squared is here, so b is 5, because that's b squared is 25, so b is 5. Now if it's a hyperbola, you can use, again, you can use a squared plus b squared equals c squared. So if we know what a and b are, or a squared is 144, I'll just grab my calculator. So a squared, 144, plus b squared, that's 25. That's 169. So c squared is 169. So c would be 13. C is 13. So I just used the Pythagorean theorem to get that. Okay, I like to graph these. I really do think that's helpful to see it, to visualize it, to get the right answers. All right, so what do we got here? Okay, they have the center of this shape is at -3, 2. Okay, 1, 2, 3. -3 up 2, that's the center. All right, the x was first in this problem, and then we said a was 12. So you want to go along the x-axis out 12, like a distance of 12 out, one from the center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That puts you way over here. That's from the center. This was the center again. And if you go, since a was 12, if you go, and that was under the x, that's a vertice. That's a vertice. Okay? And C was 13, so if I go like one more space, that was 12. If I go one more space, that's where the focal point is. C was 13. So, I mean, I'm just kind of sketching it real fast. But yeah, it makes me see that it goes like side to side. So it's a horizontal hyperbola because the number under the x was bigger, like x came first in the problem. So I know it's like horizontal. Okay, so determine the vertex. Oh, it should say like vertices. It should say vertices and the foci. Okay, so the vertices, well, one vertice, like I said, we had to go like 12 spaces over from the center. Like we had to add 12 to this. So -3 plus 12, it put us over at 9, 2 for one of the vertices. I'll just put V for vertice. And there's another vertice because you go the other way. If I went 12 this way, so if I took -3 and did -12, I'd be at -15, 2. It'd be like way over here, and yeah, it gets kind of, I know I don't have a lot of room to sketch. But yeah, those are your two vertices, 9, 2 and -15, 2. And then the foci, well, the foci, you go off of the C is 13, it's just like one more space over. One of the focal points is at 10, 2, and the other one is at -16, 2. Because all I did again is went from the center, and you can add 13 to this number or subtract 13 from this number and go each way to get to the foci. The focal points, yep, the foci. All right, keep going. Now next is a parabola again. Okay, write the equation of a parabola with a focus at 2, 2 and a directrix at x equals -2. Well, again, a quick little sketch will help. Focus is at 2, 2, so right here. Directrix is at -2. That'd be back here. Directrix is a line like on the other side. Well, your vertex would be between those. This is your focal point. This is your focal point. This is the directrix line. The vertex is halfway between those. So that puts the vertex right here, because this was at 2, 2, and this was at -2. So the vertex would be at 0, 2. Okay, so your vertex is at 0, 2. And then if I kind of just make a quick sketch, remember I told you earlier the focal point is always inside the parabola. So this parabola, I can see once I sketched it here that it opens to the right. So it would have the y part of the formula squared. That's just how, the ones that go left and right, the y part of the formula is squared. So the vertex is 0, 2, that's h and that's k. So it goes y minus k, k is 2, so it goes y minus 2 squared equals 4p times x minus h. X minus h, well h happens to be 0. P is the distance from the vertex to the focus. So you can see it in your picture. P would be 2. P equals 2. Sorry, I want to write P equals 2. It's just a distance from this vertex to the focus. So 4 times 2 is 8. So here would be 8 for the final answer. And you'd have y minus 2 squared equals 8x. You don't really have to write x minus 0. That's just x. So you can just write 8x. And that's the answer for that one. Y minus 2 squared equals 8x. Okay, next one, number 7. It's talking about an ice rink is in the shape of an ellipse. The rink is 96 feet long. So pretty long, like the distant length all the way is 96. From here all the way to the end. Yep, like this distance here is 96. And the width is 64. So you have to think about the center. It says it's centered at the origin. So the center right here is like 0, 0. So if this whole thing is 96 for the length, you could figure out half of 96. Okay? 96 divided by 2. Half of 96 is 48. So the distance from the center to like one of the edges is 48. Does that make sense? That's A. A equals 48. And then same thing with the width. They told you the width was 64. So you need to figure out like half of that. Half of 64 is 32. 32, that's B. B equals 32. And they made it long and wide. We're making it horizontal. It's a horizontal ellipse. Okay. So it says find the location. Oh, first write an equation of it. Okay, so write the equation. So the 0, 0 was the center. So that's the h and the k. All right, so it's going to be, I'll write the formula, x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, that's our formula. So our formula is going to be, well, h and k are both 0. So see, it's just going to be x squared on top. It's going to be x squared over a squared. Well, a is 48. So I have to take 48 squared. It's a big number. 2,304. 2,304. I know that's weird sometimes when you get big numbers on a test, but that's how it is. B is 32, so I have to do b squared. So I have to take 32 squared. That's 1,024. So on this one I have to write 1,024 equals 1. So that's the equation that they wanted. Now to find the location of the foci, you have to use a squared minus b squared equals c squared. You have to remember that for the hyperbola is like the normal Pythagorean theorem. But on the ellipse it's a squared minus b squared equals c squared. So a squared was 2,304, b squared was 1,024. I have to subtract those to get c squared. So if I subtract those, I get 1,280 equals c squared. So c equals, take the square root of that. Let's see, it's an awfully big number. We could put it as a decimal or radical form. It reduces to, let's see, square root of 1280. Let's check it out. Square root of 1280. 35.78. 35.78. Or you could simplify your radical. I know it's kind of a pain, but you could simplify the radical. 1280 if you divide it by 5, you get 256. Square root of 256 is actually 16. So it comes out to 16 square root of 5. Instead of a decimal. Yeah, a lot of times in your upper math classes, they want you to leave it in radical form. So I'd leave it 16 square root of 5. So then your foci, the locations of your foci, would be your focal points. You know, you'd start at 0, 0, and you'd add 16 square root of 5 this way and go 16 square root of 5 to the left. So your focal points, foci, are 16 square root of 5, comma 0, and negative 16 square root of 5, comma 0. You know, like plus and minus, because you just go left and right from the center. All right, almost done. Determine the conic represented by this. Okay, it only has one variable squared. It only has x squared. See, the y side's not squared, so I know it's a parabola. X is squared, so I know it's a parabola that goes up or down. I know it's like vertical, up or down, since x is squared. It happens to have a negative 8 right here. That's where the formula has like 4p usually. So if I see a negative number, so I know this parabola actually opens down. It should be something like this when I graph it, since there's a negative right there. Since there's a negative there, I know it's going to open down. All right, so your vertex of your parabola is 1, comma, negative 2, based on the numbers here by x and y. Positive 1, negative 2. That's your vertex. All right, so I'll go over my graph and put that on my graph. 1, negative 2. And like I told you a minute ago, I see this negative 8 here, so I see it's negative, so I know it opens down. That part of the formula is always 4p, so it's like 4p is negative 8. So if I divide by 4, I know p is negative 2. So I know like my focal point would be 2 down from the vertex. This is my vertex. So I know my focal point is like right below it, 2 spaces down. And I'm not going to get real fancy. I know it goes down, so I'll just draw one that goes down. That's good enough. Because it didn't say any other specifics about it. It didn't even say you had to do the directrix. So that's good enough. All right, number 9. On number 9, same type of deal. You want to figure out what shape it is and then graph it. If you see a plus here, and both variables are squared, and there's different numbers down below, then that makes it an ellipse. This one's an ellipse. My center of my ellipse is based on the numbers up by the x and the y. So the center of my ellipse is 2, comma, negative 1. So I'd go on my graph, 2 negative 1s over here. Under the x, it says 64. That's under x. X goes left and right. The square root of 64 is 8, like a equals 8. So I could go 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 to the right and 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8 from the center. And then under the y part of the problem, there's a 16. That's b squared, that's 16, so b equals 4. So I know I can go up 4 and down 4 from the center. 1, 2, 3, 4 up. 1, 2, 3, 4 down. And then try to kind of sketch an oval shape of your ellipse from those dots. There, that's good enough. See, you don't have to take a lot of time on it. There we go. Done. Last one. They have 2 equations, and it's like you're comparing them. You can graph both of them. Find where these 2 graphs intersect, where they intersect by graphing. Okay, well, the first equation over here has a minus in it, so I know this one's a hyperbola. And the second one over here has a plus, so that one's the ellipse. Both variables are squared, it's plus, that's the ellipse. Okay, so they're very similar. This hyperbola has a center of 0, 1. Same on the ellipse. The center of this ellipse is 0, 1. They made them really similar, and they're just trying to get you to see the differences between them. So they both have a center of 0, 1. So I'll graph that. Under the x, there's a 4. So that means like a equals 2, because that's always a squared. So on the x-axis, you should just go 2 each way, 2 to the right, 2 to the left from your center. And then under the y, there's a 9. That means b is 3. Square root of 9 is 3. So you go up and down from the center 3 spaces. 1, 2, 3. And when we make this hyperbola, they usually kind of make a box then based on those distances from the a and the b distances from the center. They make like a box, and they make an X through the box. It just helps you to sketch it like really accurately. And we have to be kind of accurate on this one because they want to know where they intersect. And this hyperbola started with x squared, so I know it's going to be a hyperbola that opens left and right. It's a horizontal one because it starts with x. So this hyperbola goes kind of like this along these asymptotes, these dotted lines that I just made. So this hyperbola looks like that. Okay, well your ellipse is very similar to this. The ellipse has the same like a and b numbers. So your ellipse, a is 2 again, because it says 4 under here. So I already kind of have those marked. And b is 3, because it says 9 right there, and that's up and down 3. See, your ellipse just is like an oval shape in here, kind of in between. So where does the hyperbola and the ellipse intersect each other? Where they touch, like right on these points here. See, that oval shape hits the ellipse on those vertices. So they intersect at 2, 1 and -2, 1. That's what they were looking for. Where do they intersect each other? Where do they hit? 2, 1, and because that's like an oval inside of these curves, these arching curves. And that would be the answer for that one. Okay, so I hope this video helps, and then you can watch this and be prepared for your test.